Yesterday we started solving equations by doing one-step equations where you only had to do one operation in order to find what x equaled or to find what the answer was. Today we're going to step it up a little bit and start doing two-step equations where you're going to have to do two different things in order to find the answer. Before we go into examples of two-step equations, we're going to quickly go over the steps for solving any equation, which I have listed here on the board. So you can write these down on your notes for today as a reminder. You're going to do it again tomorrow. That way, the more we practice this, the more it'll be inside your head and you won't have to think about it in the future when you're working on these problems. So the first step, always, anytime that we're doing any sort of math problem, is to distribute. We want to get rid of the parentheses. We can't solve or figure out what x is if there's any parentheses in the problem, because parentheses put things together, and those things have to be separated in order for us to find the answer. So our first step is always to distribute because we want to remove the parentheses. The second thing we're going to do is draw the border. We draw the border to separate the left side from the right side of the problem. After that, we're going to combine like terms. Remember that we can only combine like terms on the same side of the equal sign. We can't combine an x on the left side with an x on the right side to get 2x. Those are two separate sides, and there's other ways that we can move the x's and put them together in the later steps. The next step is to add or subtract. We want to add and subtract all of our x's and numbers so that we can get all the x's or all the variables on the left side of the equation, and then we want to get all the numbers on the right side. And the last step is for us to multiply or divide so that we can get 1x equal to an answer. So these are the 5 steps that we're going to use anytime that we're solving an equation or an inequality. So let's go over a couple examples of how to do some two-step equations. I'll slide on over. So an example of a two-step equation would be like 3x plus 4 equals 13. We want to try to figure out what number, when we multiply it by 3, then add 4, is going to give us 13. So in order for us to do this and solve it, we're going to sort of work backwards using inverse operations so that we can get our x by itself. So we just went over the notes on how to solve an equation. The first thing we would do is distribute. We don't have any parentheses in this problem, so there's nothing that we need to distribute out. Second step, draw the border. So I'm going to draw my line down the equal sign so I can separate the left side of my problem from the right side. Next, we're going to combine like terms on each side of the problem. So on the left side, I have a number with a variable, and I have a number by itself. Can't put these things together because they are not alike. These are not like terms. So we can't do anything there. We can't simplify there. On the other side, on the right side, all we have is the number 13. So there's nothing to combine it to, so there's no combining necessary. Next, we're going to add or subtract. So I want to make sure that I have all the x's on the left side of the border, all the numbers on the right side. So if I look at my problem, I see we only have one x value. We only have one x, and it is already on the left side. So we're good there. We don't need to move any x's around or subtract anything or do anything else to get it on the left side because it's already there in the problem. We do, however, have a number on the left side also. So I don't want any numbers on the left side. I want them all on the right side of the equal sign. So since I'm adding 4 in the problem, I want to do the opposite or the inverse operation to get rid of the 4 on this side. So the opposite of adding 4 would be to subtract 4. Yes. So I'm going to subtract 4 from this side. Whatever we do to one side of a problem, we have to do to both sides so that we can keep the equation equal. So I'm going to subtract 4 from this side of the problem. 13 minus 4 is going to give me 9. So I have 9 on the right side On the left side, all I'm left with is this 3x. 4 minus 4 is 0. It cancels each other out. It goes away. I don't need to put a plus 0 over there. I already know that there's 0. There's nothing there, so I don't need to put a number to represent it. I'm trying to get rid of things so that all I have left is the x equals some sort of answer. So 4 minus 4 is 0. Gets rid of it. All we have on the left side is the 3x. That was the first step. That's the first step we did. It's a two-step problem, so we're going to have to do one more thing in order to find the answer. So we've added and subtracted. We've put all of our x's on the left side. We've put all of our numbers on the right side. Now we go to the final step, step 5, which is to multiply or divide so that we can get x equal to our answer, or 1x equal to a number, which would be the solution. So in the problem, we have 3 times x. In order for me to get this x by itself, I need to do the opposite, or the inverse operation of multiplying. I want to divide. I want to divide this by 3, because 3 divided by 3 will give me 1, and I have 1x. So I divide by 3. Have to do the same thing to both sides in order to keep the equation equal. 3 divided by 3 is 1, and when you cancel out or cross it, you can see that it makes a big 1 to remind you. So I have 1x equal to 9 divided by 3 would be 3. And that's my final answer. I don't necessarily have to have the 1 there. I can get rid of it. If I want to box my answer, I could turn that 1 into part of my box to show the solution. But that's the final answer, x equals 3. We can go back and check it. I can put the 3 in here for x. 3 times 3 is 9. 9 plus 4 is 13. It all works out. All right, so now we're going to do another example of a two-step equation. So we're going to write a problem on the board. We got, let's see, x minus 4 minus 3 equals 2. So here we have x divided by 4 minus 3 equals 2. We're looking for the number that when we divide it by 4, then we subtract 3 from it, is going to give us 2. Okay? So we're still going to use our order of operations. We're going to go through everything like we normally do, going through each step whenever we solve an equation or an inequality. The first thing that we would do when solving an equation or inequality is to distribute and get rid of any parentheses in the problem. This problem doesn't have any parentheses, so we don't have to worry about that. Second, we're going to draw our border. Draw the border to separate the left side from the right side. Third step is to combine like terms. On the left side of the problem, we have an x and we have a number. A variable and a number, we can't combine those together. Those are two different things. They are not alike. So there's no way for us to simplify that side of the equation any more than it already is. On the right side, all we have is a number. We just have the number 2. There's nothing to combine it with, so there's no combining like terms on that side either. Fourth step is going to be for us to add or subtract, where we get all the x's on the left side and all the numbers on the right side. Looking at the problem, you can see all of our x's are already on the left. We just have the 1x, the 1x term. It's already on the left side, so we don't have to do anything there. We do have a negative 3 with it, so we want to get rid of that and move it over to the right side. So since we're subtracting 3 in the problem, we want to do the inverse operation of that, the opposite, which should be to add 3. So we're going to add 3 to both sides. Negative 3 plus 3 cancels out or gives me 0. 2 plus 3 gives me 5. Haven't done anything with the x minus 4, so that just comes down in the problem. I'm sorry, x divided by 4, not x minus 4. X divided by 4. And now, since we have all the x's on the left side, we have all the numbers on the right side, we can do the final step, which is to multiply or divide. In this problem, the x is being divided by 4 to get 5. So whatever x is, we divide that by 4 to get 5. So in order to get x by itself, we want to do the opposite or the inverse operation of division. The opposite of dividing is multiplying. So we're going to multiply this side by 4 and this side by 4 to get x by itself and see what our answer is. So I'm going to multiply this times 4 and this times 4. 4 times x is 4x. Remember, these whole numbers, when you're multiplying fractions, since this is not a fraction, I can put anything over 1 to turn it into a fraction. And then when we're multiplying, we just multiply across. 4 times x is 4x, 1 times 4 is 4. On the right side, 5 times 4 is 20. You can see here on our equation that we have 4 divided by 4. That's going to cancel out. 4 divided by 4 is 1. So we're just going to be left with 1x there on the bottom. Four divided by 4 is 1. So I have 1x equals 20. And there's my answer. Again, we can use the 1 to box the answer in if you like, or you can just leave it 1x equals 20. Either way is correct. I can go back and check it. Put 20 in for x. 20 divided by 4 is 5. 5 minus 3 equals 2. We got the right answer. One more example of a two-step equation that I would like. So one more example of a two-step equation would be something like this. Let's try one where we need to distribute. So we have 1/2 times 2x plus 4 equals 6. So we're going to go through our steps. We're going to end up doing two different things because this is a two-step problem. And then we're going to find out our answer. So again, we're going to go through our steps. First thing we do anytime we're solving any equation or inequality is to distribute and remove the parentheses. So I'm going to multiply everything inside the parentheses, the 2x and the 4, by 1/2. So 1/2 times 2x, 1/2 times positive 4. 1/2 times 2, and this is why y'all have calculators, because if you're not sure, it's not 4, all right? It's not 1/4. 1/2 times 2 is 1. It's 1x. This is why we'll be using our calculator soon. You want to make sure you type these things in. You have a phone that has a calculator on it. You can use that to do these simple arithmetic equations. That way you can make sure you get the right answer. 1/2 times 2 is 1x. 1/2 times 4 is 2. Next step, after we have distributed, is to draw the border. So I'm going to take my marker and draw a line through the equal signs. Step 3 is to combine like terms. On the left side of the equation, I have an x and a number. Can't combine those, so that can't be simplified any more than it already is. On the right side, I have just a number by itself, so there's nothing to combine it to. Step 4, I'm going to add or subtract to get all my x's on the left, all my numbers on the right. So I have all my x's on the left already. I have x, I have 1x here. There's no x's on this side. I do have a number, and I want all my numbers on the right side. So I want to get rid of this positive 2 by doing the inverse operation. The inverse operation of adding would be subtracting. So I'm going to subtract 2 from both sides. Two minus 2 is 0, or it cancels out. 6 minus 2 is 4. And I have 1x here. Now, the next step would be for us to divide multiply or divide by the number in front of x to get the final answer, because we're looking for 1x equals a number. But we already have that. We're already down to 1x. If I divide this by 1, I'm still going to end up with 1x, and if I divide 4 by 1, I'm still going to end up with 4. So in this particular case, when the x doesn't have a number other than 1 in front of it, or when the x only has a 1 in front of it, then we're done. We don't have to go to another step of multiplying or dividing, because it's already as simple as it's going to be. So we already see that our answer is 1x equals 4. And again, you can leave it like that. You can use the 1 to create a box to show your answer, however you want to do it. Either way is correct. I want to go back and check. I'm going to plug 4 in for x. 2 times 4 is 8. 8 plus 4 is 12. And I did the parentheses first because that's the order of operations that you learned in 6th, 7th grade. So we have 12 here, and then half of 12, because 1/2 times 12 would give me 6. So it all checks out.